6.3 is modeling data with a line of best fit. So we have a few definitions to look at. What a line of best fit does is it's a line that you are going to draw through data when you're given data that doesn't necessarily follow a nice linear equation or linear function. The data is kind of scattered around a little bit, but you can draw a line through it in order to do some hypothesizing as to what the correct answer might be. So line of best fit is a straight line that best approximates the trend in a scatter plot. Regression function is a line or curve of best fit developed through a statistical analysis of data. Interpolation is a process used to estimate a value within the domain of a set of data based on a trend. So interpolation, you're looking at your data that you have, so between your end and your start and your end data, and hypothesizing about that data. Extrapolation is when you are looking at the values outside the domain, so outside the values that you're given, and trying to come up with a trend or make some predictions. So, I apologize for the shape of your notes for this one. I hadn't saved a copy of a blank one, so I had to do some deleting as best as I could in order to make this work. So it says the table shows how the outside air pressure changes as an airplane rises after takeoff. So we want to create a scatter plot on our graphing calculator and then plot the points on a graph. So first we'll just plot these points on our graph, and then we'll go to the scatter plot on the calculator. So at across the bottom here is our altitude in kilometers, so our x values. This is the independent values, and our y is our air pressure, because that's what changes with altitude. So that is our dependent values, or our y. So to plot these, we have 0 and 101, so that's basically right there. 1 and 80, 2 and 74. Oops, I didn't move that one over far enough. So 2 and 74, approximately there. 3 and 62, so it's just above. 4 and 55. It's going to be a little bit better than halfway. 5 and 46. So approximately there. So that's what our data looks like. So now if we go to the calculator, we can put our data in here. Okay, so to start this, we went into the second and list. Oh, sorry, did that wrong. Second stat plot. Where'd it go? I keep telling you the wrong one. Oh, I just need the stat button, that's why. Okay, stat. We want to edit. So our list 1, you go up to L1 and hit clear. It'll clear that for you, so clear and enter. So I'll go back up to list 2, hit clear and enter. It'll delete any data you have in there. Okay, so we're starting at 0, 1, okay, 0, whoops, to 5. Now our list 2 was 101, 80. I hope that's a 101 there. Yeah, 80, 74, 62, 55, and 46. Okay. So now our window for this one, because our other one we had set, my window will be set from our last one. So our x went from 0 to 5. So you could do in the negatives here, you could say, let's go from No, actually, let's just leave it at 0 because we're not going to have an altitude less of 0. So x maximum, you could go to 10. X scale, might as well go up by 1s. Y minimum, for this one, I'd probably start it. I'm just going to see on my screen here, what did I do? I guess I did start at 0. Okay, so we'll go from 0 up to, let's say, 120, and we can go up by, I guess I did 20s there, didn't I, on the, so if we go up by 20s. Okay, so once you've got your data in there, good idea in case you've been doing anything else. Now go to your stat plot, which is above your y equals sign. So second, oh, okay, so my plot is on, I'm good there. And I have the scatter plot, I've got list 1, list 2, that's all good. So if I go back to here, that is all turned off. So everything is okay, so now we just press graph. So there is our graph for this one. So now what we want to do is, continue with, so what term would best describe this trend? Well, looking at it wherever we are, it does have a bit of a linear, it's almost a line, so we would say that it is linear. So even though it's not a perfect line, it's pretty close to being a straight line. So D part says write the linear regression equation to this data. So we bring this back up, and we want to do that back on our graphing calculator. So in order to do that, we press our stat button. We want to calculate, and we want to go to number 4, which is our linear regression, our X list, our Y list, so enter, enter, enter. We want to calculate this, hit enter, and it tells us, oops, I got the wrong page up here. We have negative 10.34 is our A, and 95.52 is our B. Okay, so let's, oops, I'm going to have to put this down. So it'll be y is equal to negative 10.34x plus 95.52. So this is our linear regression general statement. So E part says, what will the air pressure be at an altitude of 6 kilometers? So we need to do, because 6 kilometers is outside of what we're looking at, so if we did a line of best fit on here, drew our own line, and I'll try to do this as best as I can. So our line we're looking at going through the middle of our data, so that we've got about the same amount on the top and the same amount below it. So I've got 1 on top, 2 on top, 1 below, 2 below, and kind of 2 right on it. Oops. So at the value of 6, based on this, 6 kind of crosses right here. Oops. This is 6 right in there. So if we go across and take a look, it's just between 30 and 40. So you could say it's a little bit lower, so you could, even if you said about 33 kilopascals at 6 kilometers. On your calculator, if you wanted to graph this, you could put in those values. Y is equal to negative 10.34, 10.34 x plus 95.52. Oh, what didn't it like? Oh. Well, that's not telling me what I wanted it. What was I missing on here? I want to go into there. Okay, I'll have to check and see why I didn't do that, but when I do, I'll show you guys. So if we look off of the data there, or off of this, we can see what is going to be the correct or approximate one. So F says, at what altitude would the airplane be if the pressure was 18.5 kilopascals? So 18.5 kilopascals is again outside of the data that we have. So 18.5, so we're going to do extrapolation. 18.5, this is kind of where my dotted line is going here, hits it at about right here, which would be about 7.5, a little bit less based on my line. So we would say this is at about 7.4 kilometers. Okay, the next question. Oh, I have to flip the page. The 1-hour record is the farthest distance traveled by bicycle in 1 hour. The table below shows the world record distances and the years after 1990. So when we're doing this, we're using our x min is equal to 1, x max is 30, y min is negative 10, and y max is equal to 110. So it says create a scatter plot on the graphing calculator. And I cheated and put the line of regression. I forgot to take that off of there. So let's go to our graphing it here. So years after is 6 and 78.04. So these are going up 2, 4, 6, 8. So 78.04. Going to be approximately, well, it should almost be right on the line. The next one was at 8 and 79.1. Oh, sorry, that was at 6. Oh no, that was supposed to be at 6. So 8 and 79.1, so it's going to be a little bit higher. Next one was 6, 8, 9, and 81.16, so just over. 10, no, 12 and 82.6. Just a little above 80 or 82. 13 and 83.72. 82.4, so, whoops, yeah, that's right, 13. 14 was 84.22. be right there. 17 was 86.77. And then 19 was 90.6. Okay, so that's what our data looks like. Our line of best fit then, if we draw that in, you can see where I've got it on here already. Oh, why didn't they give me a... I don't know if that's going to make a straight line or not, but we'll see. Nope. Okay, so let me try this again. Having issues. Oh. Making me angry. Okay, well, I'm not going to get it to draw a straight line for me for whatever reason, so I'll do my best. And again, when you're doing it, I should have picked a different color. You want to have about the same number above and below your line. So then C part says to write the linear regression. So again, we go into our calculator. We want our we're going to stat edit to list 2. We're going to clear that one. List 1, clear, and start putting your data in. So your years are your X values and your Y's are your times. So we have 6, 8, 9, 12, 6, 8. Oops. $17, 18, 19. Okay, list 2, 78.04. 79.14. 81.16. 82.6. 83.72. 84.22. 86.77. 87.12. And 90.6. Okay. So now for our window, we wanted to change this to -1, 30, Y max, Y min, I mean, was -10, and 110. And we could go up by, we were going up by 2s, I guess. Okay, then if we graph it, no, window range, they didn't like my window range. Window, what did we miss? -1, 30. Oh, Y scale was 110, that's why. Y min was supposed to be -10. This is supposed to be 110. Go up by 2s. I think that was normally a 1. Oh, it's got that Y equals on there. So ignore that line. So this, because I switched that other thing, plot 1 should be on. Hit enter. We want it on. Okay, and the rest is all okay. Okay, now we should be able to graph. There we go. So up there is what we're looking at. Now we want to do our line of regression. So we press our stat button. We want to calculate. We want line of regression. List 1, list 2, so just hit your enters. Okay, so there we have 0.858, which you have over there, and 72.64, we rounded to a 3. So based on the data, what was the world record distance in 2000? So if I go back to my graph, so in 2000, that's between our data that we have, because remember this starts in 1990, so in 2000 would be year 10. So in year 10, if you go to your table here, or sorry, to your oh, no, that's not going to give it to you. Sorry, this one won't work. I thought it would. So if you go right onto your graph, whoops, I have to take that down so you can see it. There's two ways of doing it. You can look onto your graph, so let's write this in. 0.858x plus 72.643. So in year 10, what you could do to find out what that data is, you could just enter a 10 in there. So I could look off of my chart here, year 10, it looks like it's about 81 or so. So 81. Or if you want to be more exact, substitute. Y is equal to 0.858 times 10 plus 72.643. So that's going to be 85. And if you do your calculation, that doesn't seem like it's going to be right, but it should. Not sure why that doesn't work. Have to check my math on that, but about 81 or 81.23. So then it says, based on this data, when might the world record distance be? 95 kilometers. So 95 kilometers again is outside, so 92.4. So 95, if we go across, oh, I should do a different color. Let me do purple. Well, if I had extended my line, you'd see it hits it at approximately here, which would be about 26 years. Okay, and we should be able to then do the reverse and substitute and solve for it. Well, I know why. I was doing my math wrong. This one works, because this would be 8.58. I was going, like I was multiplying by 100. So 8.5, so 72.643 plus 8.58. So that gives you, there, 81.22, so a little bit more exact. So you could do the same thing here and substitute in and say 95 is equal to 0.858x plus 72.643 and substitute or solve for your x value. So your questions are there. Play around with it a little bit. I'm gonna do, I have to change something on my other one, and I'll show you in class how to do that, plot the line of regression on your calculator.